is substitution method. Okay, so you're going to want to be paying very close attention. You're going to want to put your phones down. If you have a laptop that's not on OneNote, you need to close it down because this requires focus. Okay?
You just said it wasn't hard, You've never said it before.
Yeah, you never.
I'm telling you, you've got to pay attention, that's all. All right. So, we've done a lot of different kinds of deriving. Okay, we've learned how to do the basic rule of deriving, right? And then we had a product rule, quotient rule, chain rule. Okay, so we have to be able to undo our things, so integration allows us to undo. So we learned how to undo basic. There is no way to undo product or quotient, so we don't have to do those. But what we're doing today is undoing the chain rule. Okay, so what we're going to do is we're going to practice doing the chain rule, understand what we are doing, and then we're going to go backwards. Okay, and it's really, for the most part, not much different than doing a basic. Okay, there's just a little bit more. There's actually just one more step involved. Okay, so let's see if you remember how to derive using the chain rule. Okay, so chain rule is anytime you see a quantity with an exponent, the first thing you do is what? Good. Okay, so you multiply by the exponent, and then what happens to your new exponent? You subtract 1, and then what's that last piece that you have to not forget? Good. You multiply by the derivative of the inside, which in this case would be 2. Okay, and I'm not going to simplify right now because we're not working on that. We're just understanding what we're doing for chain rule. Okay, so we multiplied by the exponent, subtracted 1 from the new exponent, and then multiplied by the derivative, right? Okay, try question 2. What happens here? Very similar, slightly more complex. What's different this time? Okay, so in this case we have to multiply the 5 by the exponential 5, which gives us 25. Okay, we're still going to subtract 1 from the exponent, which becomes what? 4. And then what do I have to do? Multiply by the derivative. So what would the derivative be for this one? 6x plus 4. Okay, so if I'm going to go backwards and do an integration, I'm basically going to do the exact opposite for all of those steps. Okay, the first part of that was just like our basic rule. Okay, we multiplied by that exponent, subtracted 1. So to undo that scenario, we're going to divide by that exponent and add 1 to the exponent. That's just basic. But how are we going to treat that derivative piece? If deriving, we multiply by that derivative, what are we going to do when we integrate? We're going to divide by the derivative of the inside. Okay?
Why would you even need to do that? Like, because if you're just like given this thing, they could you just like divide by the 5 and add the 1, you still have the same inside.
Wait, say that one more time.
So like, okay, so you divide by plus 1 and plus 1.
Right.
Which will be 5. And then you're...
Are you talking about this red equation?
Yeah.
Okay, let's do it. Let's say we're going to integrate this. So, oops, I forgot my notation here. Let's go backwards. Let's take this and go backwards. And I'm even going to write it like this, so you can see the go backwards part. Okay. So if I'm going to go backwards and find the original function, we're going to do the antiderivative or the integral. Okay, the first thing I have to do is identify the piece that's inside the parentheses and which piece is the hook-on factor. Okay, so the piece with the exponent is always the inside. So I want to just give that a blanket statement of what we're going to call it. Okay, so instead of we call it the inside stuff, let's make it more official. In calculus, we call that the u. Okay, so they define it with a variable of u. So we say the u is the inside stuff. I've been using the word stuff. Okay, but just so you see that that's going to come into play here. Okay, so what would the derivative of my stuff be? Okay, so my derivative is 6x plus 4. So you can see that that's the hook-on factor, right? Okay. Yep, so all we're going to do is we're going to ignore the 25, and we're going to ignore the hook-on factor for a second, and we're going to integrate the quantity to the 4th power. Okay, so with my basic rule, I'm going to start by adding 1 to the exponent. So if I add 1 to the exponent, what does it become? 5. So if I have a new 5 up in the exponent, what do I have to do? Divide by the 5. And now, since I'm undoing that hook-on factor, I'm now going to divide by the derivative of my inside piece. So the derivative of my inside piece is 6x plus 4. Okay, we do have this plus c because we are integrating. Now check it out, what cancels out? The 6 plus 4s, because we're undoing the chain rule. And then what happens with 25 over 5? Turns to 5. So we have 5, 3x squared plus 4x to the 5th plus c. So you can see that those are equivalent. Okay. All right, so let's do another one that you haven't seen before. Let's try this example. Okay, so I have the piece that has the exponent. That's my stuff. So we're going to identify that right away. Okay, we're going to call it the u, just so we're all on the same page. What is the value of my u? Sure. We'll just go like this. Okay, good. The inside, good. X cubed plus x. Okay, and at some point you might be able to start doing this in your head, but I'm just going to write it down so it's very visual for you. I want to derive that and just make sure that that's the stuff that's left on the outside. Is it going to cancel out? So what is the derivative of my u? 3 plus 1. So is that outside piece? It is. Okay, so now I can do my reverse chain rule. Okay, so I'm going to start with this piece. I'm going to ignore that extra piece there. Whoops, not integration. We are integrating it. So I'm going to take my quantity and I'm going to add 1 to the exponent. So what's my new exponent going to be? 6. Okay, and if my new exponent is 6, what else do I have to do with it? Divide by it. Then I also have to divide by the derivative of the inside. What is the derivative of the inside? 3x squared plus 1. Not every time. So the piece of this that becomes really important, and Morgan kind of started thinking about this, is like, well, is it always going to be the derivative there on the outside? Not always. Okay, for this reverse chain rule, do you hear me saying this is called the reverse chain rule? Reverse chain rule. Right. Although U-substitution is directly related to it, and I'll show you U-substitution here next. But for the reverse chain rule to work, that derivative of the inside has to cancel out perfectly every time. Okay, we can do a scenario where things are slightly off and we can make it equivalent. Like this one. Let's do this one. Did that square root scare you? Okay, let's rewrite it so you're not so scared. 2x plus 1 to the 1/2. Okay. All right, so the first thing that I want to do is identify what is my u piece. Okay, what's my u? My inside. Clearly 2x plus 1, right? Okay, and now I'm going to derive it. What is the derivative of 2x plus 1? 2. So do we have a 2 hanging out up there? No. So in this scenario, when I have a constant like this, I can multiply my integral piece by 2. Okay, now watch what I do. This is very tricky. See if you follow. Okay, so I'm going to multiply by 2, so it is my hook-on factor piece. But if I multiply an expression by 2, I also have to undo it. So if I multiply by 2, what else do I have to do to keep it equivalent? I also have to divide by 2. So what I'm going to do, instead of dividing by 2 in the integral, I'm going to divide by 2 on the outside. Okay, and leave that 1/2 out, and we'll play with it last.
Wait, so when it doesn't show.
Right, we gotta make that inside piece become our hook-on factor. Okay, so we have to do a little bit of algebra to make that work. If I'm missing a 2, I can multiply by 2, but I have to keep it equivalent and undo it. So that undo is going to go on the outside of the integral. Okay, you ready? Okay, we're going to integrate. So the 1/2 we're going to leave alone. We're not touching it. Okay. We're going to integrate my u piece, so we're going to keep the 2 there. And we're going to add 1 to our exponent. So if we add 1 to the exponent, what's 1/2 plus 1? 3/2. Mike and Chaz, are you guys paying attention?
Yes. Sorry.
So what do I also have to do here? Divide by 3/2. And then, because my exponent is 3/2, right? And then I also have to divide by the derivative of the inside. What is the derivative of the inside? Which is 2. Right. You were just a little ahead of me. Okay, we have a plus c because we just did an integration. Okay, let's do the obvious stuff, what things cancel. The 2's. Okay, I have a 3/2 sitting there in the bottom. If I divide by 3/2, what is that the same as? Good, multiplying by 2/3. So I'm just going to do this very slowly. Okay, so I canceled the 2's, I flipped my fraction, and now I can multiply the front stuff. What is 1/2 times 2/3? Good, 1/3. Everybody good there? Do you want to do another reverse chain, or do you want to do, are you ready for a U-sub? One more reverse chain with a harder scenario, like we could throw in, what do I got? I think I have like a trig. You betcha. You betcha. Yeah, well, and U-substitution, which is really similar. They're really close to the same. It just is a substitution method is what it is. Okay, you ready for this? This one actually might be a little easier to do, a U-sub one. I don't want to go there yet. Yep, there's a times 5 in the end there. Okay, you ready? Okay, so the first thing I'm going to do is identify what my inside is. What's my inside? Okay, so the inside is 5x plus 1. Okay, what's the derivative of that? 5. So am I okay? Do I have a 5 hanging out? I sure do. Perfect. So I don't have to do anything to this one. I can just go straight to the integration. Okay, so what I want you to notice here is that I'm integrating the secant squared. See that? Okay, so when we integrate trig functions, this is when you grab your little cheat sheet with all your rules and you look for secant squared. Okay, what is the integral of secant squared? Tangent. Perfect. Okay. We don't have to worry about the k. And I personally, by the way, when you guys write down your definitions, I probably would totally ignore the k's and take that out. Okay, because technically all they're doing is they're doing a reverse chain. Okay, and that's why they're divided by the k. The k is simply the derivative of the inside. And in fact, it's only in a very simple scenario. Okay, when your x is just an x, which is really like 5 cases out of 100. Where did I go? I lost my spot. There we go. Okay, so the integral of secant squared was, what did you say? Tangent squared. So, or just tangent. So it's going to be tangent of our stuff. Oops, I just wrote a u instead of an x. Okay, and then I have to, well, I don't square it because it's just, secant squared is literally the integral. Like tangent is the integral of secant squared. So we don't worry about the exponent. It's not a basic rule.
Wait, what? No, don't you add 1 to the exponent?
No, because it's not a basic rule. We're not doing a basic rule. So, okay, so on a side note.
Yeah, we've been doing that.
I know, but it's not a basic rule. Because the integral of secant squared is tangent. There's no theory there. There's no exponent involved. Oh, okay. So wait. Okay, so now I have to divide by the derivative of the inside. So what's the derivative of the inside? 5. Okay. Oops, I forgot to add my 5 there. Okay, so for this one, when you're working with trig, you got to use the definitions. Don't add 1 to the exponent and divide by it. It's not the same thing. The integral secant squared of x, okay, in our case x is like u, okay, is tangent of x. So I'm just rewriting that.
On the last one, you like.
Okay, hold on. Okay, so in the last question, we had the 1/2. Where's that question? The 1/2 came from the fact that we were missing the 2. Okay, so remember the derivative of the inside was 2, but there was no 2 hanging out. So I had to make the 2, and to multiply by 2, I had to undo it and divide by 2. Okay, so I didn't have that scenario in this example because the 5 was there. So I don't have to multiply by 1/5 or anything. It's good to go. Okay. Can I show you the U-Substitution method?
Yes.
I think I want to pull an algebraic one and not use trig. So I'm just going to pull one down from here, I think. Let's do... It's not the homework. Let's do this one. You're okay with that? Alright, I'm going to squish this right here. It's not in an ideal location, but here we go. So this is what we're going to do. I missed the integral there on accident. Okay, so this is going to be U-Substitution method. Okay, so U-Substitution method is used in the same scenario as a chain, reverse chain. Okay, so it's the scenario where I have a quantity with an exponent. Okay, I'm missing a dx here. Okay, make sure sorry, I totally screenshotted that terribly, but we'll get there. Okay, so I'm going to write this out very sequentially and give you steps so that you can follow steps. Okay, so your first step is going to be to put your u in the front and everything else in the back. Okay, so put the u in front, everything else in the back. And this is just like an organization technique. This is not like required. So once you get this, you might not need to do this step. The u is the stuff that's in the parentheses. Okay, so our first step is going to be to take that 2 and just put it in the back of the quantity. So we're going to have our u, which is going to be 2x plus 4 to the 5th. And we have a 2x dx. Okay, so step 2 is going to be to simply identify your u. Okay, so that might be a pretty obvious step to you, but what is my u in this case? 2x plus 4. Okay, third step, derive your u. Okay, so what is the derivative of 2x plus 4? 2. Now watch what I do this time, and I was kind of neglecting to do this before, and I should have done it, but I want you to be very careful about notation here. Okay, I was being lazy before, and I didn't write the dx before. Okay, technically, anytime you do a derivative of any variable, you should technically say, if I'm deriving a, I would be doing a dA. Okay, so in this case, I derive my u, I have du, derivative of 2x plus 4 is 2, and I just did a derivative, so I have a notational dx. Okay, step 4, and this is the one that's the most complicated. This is the part where we're going to do the substitution. Okay, this is called U-Substitution Method, which means we're going to take our integral, which, by the way, what is it in terms of right now? It's in terms of x. The letter you see right now is x's. We're going to rewrite the integral in terms of u's. Okay, so we're going to write our step as rewrite integral in terms of u. Okay, or you might say something like substitute u in, whatever helps you to understand what your next step is. Okay, so that means when I'm done rewriting that green piece, there should be no x's at all. Okay, you ready? Okay, the first piece I notice is that my quantity is u, so I'm going to have u to the 5th. U to the 5th. Everybody okay there? Okay, so this piece right here was just my u, right? So I just put a u to the 5th power. Okay, so now on the outside here, I have 2 dx. What is 2 dx equivalent to? Du. It is literally replaced with du. There's no 2 because this second little red equation there says that 2 dx is equivalent to du. So that 2 gets eaten up. Okay, guess what we're going to do next? That looks really, what? No, we're still on our steps. We're not done yet. Okay, we're going to integrate the u. So our next step is to integrate. Okay, so we're just integrating this time. It happens to be in terms of u. Okay, so what is the integral of u to the 5th power? U. There you go, good. 1/6 u to the 6th. What do we need to have at the end of this? Plus c. The du, because we integrated it, right? Anytime you integrate that, integration and the du piece kind of gets sucked away. Okay, and now my very last step is that I have an equation right now that's in terms of u. But my original function was in terms of x. So now I'm going to re-sub it back, right? So now I'm going to substitute u back in. Or x, thank you. Good call. Not u. X. Let's make it big. X. Okay, so now wherever I see a u, I'm going to replace it with 2x plus 4, the whole equivalent piece. Okay, so that is u substitution. Okay, so I could have totally done that exact equation by using a reverse chain rule, or I can use a u substitution. Okay, one problem done both ways. Yes, I'll let you choose whichever one is clicking in your brain is fine with me. There will be scenarios when you have to do a u substitution. Okay, and I'll show that to you. I just want to keep practicing this one more time. Make sure we got the u substitution before we make it more complicated. Okay, can I do one more? Let's do a trig one. You guys get really scared of trig stuff. The nice thing about this is, like, when you do trig, I feel like u substitution is always easier because it just makes it more simple. It really does. I know you don't believe me, but it really does. Okay, first step. What was my first step? Put the u in the front. So in this case, I just have the cosine of the, like, I can't separate the cosine from its angle. I don't have other stuff, so I don't have any movement on my first step. So this question is, we're going to go straight into identifying my u. Okay, what is my u in this case? 7 theta plus 3. Okay, after I find my u, what's next? Take its derivative. Okay, so, wow. Derivative of u, what's the derivative of 7 theta plus 3? 7 d theta. Okay, now what do I do? Okay, I need to rewrite it in terms of u. Okay, so when I do this, okay, this is going to require a little bit of fancy footwork here. Do you notice that, okay, let's just go slow. Okay, so we have the cosine of u, right? Everybody okay with that? Okay, the end of this is d theta. But r d theta needs to be what? 7 d theta. So this is that same step where I need a 7, but I need to keep my values equivalent. So what do? Multiply by 1/7 and 7. So this is a step that I can either, you can show your work on, or you can suck it up when you do a rewrite. Okay, so I know that I'm putting a 7 there by doing, I could do the 7 up here and do a 1/7 out front. And now when I rewrite it, what is d, or 7 d theta equivalent to? du. Okay, so you see how I put this? It's kind of hard to see, but I put this right here, says 7 d theta. Okay, so I'm replacing that 7 d theta with du. Okay. All right, so we're in terms of u. Now what do? First I gotta integrate. Okay, so we're gonna integrate a cosine. So if you, maybe you know this, maybe you don't. If you look on your little cheat sheet, the integral of cosine is close, really close, positive sign. Whoops. Okay, so positive sign, so we're just going to have a 1/7 times the sine of u. We have a plus c at the end there. Okay, so I integrated. Now what's my last step? Good, substitute our x, or in this case, a theta back in. Okay, so substitute that back in. So we're going to be the sine of 7 theta plus 3 plus c. How do we do on that one? Easy peasy? Good.
We do some from homework now.
Okay. Sure. Let me pause this and then look. Okay. Do you notice that they give us the u on this front page and not on the back page? Okay, so that was really nice of them. Okay, well, sometimes. Okay, so which method do you want to do here? Do you want to do a reverse chain or do you want to do a U-sub?
U-Substitution.
Yeah. Because there's not the D.
Ooh. Well, they already identified the U piece. I mean,
Just kidding.
okay, let's do a U-sub and let's kind of make it quick. You ready?
Yes.
Okay, they did. Now, technically, step one is like shove the other stuff in the back so it's grouped together. But we're like super smart, and we can probably identify that the outside is probably going to be equivalent, right? We're pretty smart. Let's do a DU and see what the DU is and see if it's all the stuff that's on the outside. Okay, so what is my DU? Negative 15x to the fourth. So I have a dx. So is that going to just scoop it up? Good. Okay, so we're already halfway there. So rewrite this now in terms of u. So what's my integral in terms of u going to be? U to the fifth. What's the last part?
Plus C.
I haven't integrated it yet. We need a notational piece. du. du. Okay, because that du piece, that's really important. That du piece allows us to get rid of the whole 15 and the dx piece. 15x to the fourth. That's got to scoop it up. All right, now we're integrating. Integral of u to the fifth. Plus c. And our last step. Put the u back in. Make sure you use u. So u is negative 3x to the fifth minus 1. Not too bad? My 10 steps went pretty fast, huh? I just like to make the steps really, like, blatantly obvious. Like, you can't screw it up.
I appreciate that.
You're welcome. Okay, how about we skip to number 3 because question number 2 is almost identical to question number 3, but question 2 has been rewritten first for you. So if you want on question 3, you could start by pulling that quantity up if this kind of scares you. We could say this is negative 8x to the third. Actually, let me take that back. I'm going to pull this up and put that at the end so that I'm scooping it in the back. Times negative 8x to the third dx. Okay, so let's do our du. What's the du? Okay, so is that going to be a perfect replacement? Oops, I wrote mine wrong. To the third. So that's going to be a perfect replacement. Super awesome. So what's my rewrite in terms of u? U to the negative fifth. It goes on the back. du. There you go. Okay, here we go. Let's integrate it. What's the integral of u to the negative fifth? So if you add 1 to negative 5, what does that become? Negative 4. So we're going to divide by negative 4. We can go 1 over negative 4. U to the negative fourth plus c. And plug your u back in. Now, do you see how I have a negative exponent on my u? I'm going to put it into the bottom with my 4 because of the negative exponent. I'm going to write this as 4 times negative 2x to the fourth plus 5 to the fourth power plus c. Everybody follow that? Not too bad? Okay, number 4 is just the same. It's not exciting in any way. Let's do 5. There's a natural log. You haven't seen a natural log. That's one of those rules that you wrote down, or I believe you wrote down.
Yeah, we do.
Okay, question number 5. I'm going to do a rewrite on. You all right? Just because it's going to become more obvious to you. Actually, I don't know. Maybe I won't. Let's do a du. I'm going to see if you see it before I do it for you. Does anybody know what the derivative of 5 is? 0. Okay, what about the natural log of x? Ooh. Okay, that's a rule. Derivative of the natural log. Now this is an integral sheet, remember. So I'm looking kind of backwards. Do you see that number 9? Okay, so if I have a natural log of x and I'm going to derive it, the natural log of x is 1 over x. So if you didn't know that, I'd write that down on my cheat sheet right now, or someplace at the top of that sheet so you remember to write it down. What's that? The derivative of the natural log of x is 1 over x. So you could write it as or notationally you can say d dx of natural log of x is, that's correct notation if you wanted to write it that way, but don't write it if it doesn't make sense to you. It's derivative. Okay, so check this out. Is the 1 over x going to cancel on the outside? If there's an x in the bottom. It is? Yeah, right? It's the same. Like if I wrote this like this, you can really see how that's going to scoop it. Right? So your 1 over x dx is going to turn into du. Okay, so what's my rewrite? Oh, you're ahead of me. U to the 5th du. 1/6 u to the 6 plus c, and then we plug it back in. 1/6 5 plus the natural log of x to the 6 plus c plus c. Ooh, yeah, number 7. That's one we should do. We're going to do 7 and 8, and then I think I'm going to be done. And then it'll be your turn. Oh yeah, you can do that. You got it. I don't want to do the whole thing for you. I know how to do it. Alright, so question number 7. First thing I want to do is do my du. What's my du here? 12x to the 3rd dx. So, is that one going to cancel? There's like leftover stuff, right? Okay, so how can I turn 36 into 12? Divide by 3. So this is what I can do. And this may or may not take some. It depends on what you want to do. But if I divide by 3, right? If I divide by 3, what else do I have to do? So where does the multiply by 3 go? It's got to go way outside. Because we want that inside piece to be equivalent to our du, so that we can do a direct substitution. So we're going to pull the 3 way out so it doesn't touch it. Okay, ready for my rewrite? What's my rewrite? U to the 5th du. Yeah, it's a straight up du. Yeah, the 3 goes out front. I feel like they're doing lots of to the 5th powers. We're going to nail this one. Okay, so integral of u to the 5th. 1/6 u to the 6th plus c. Yeah, right? So how do you feel about multiplying 3 times the 6 right here? What's 3 times 1/6? 1/2. And then also do our substitution back in, so u can be replaced with 3x to the 4th plus 3. Sorry. Let's see. Okay. Number 8 I'm going to do, because this one is like awesome, is what I was going to say. Okay, so this is a scenario where things get a little bit more exciting and require a little bit more creativity, one might say. And I think for the most part, what I'm going to do is there will be a test or a question on your test like this, but it will probably end up being extra credit. But just so you know, if you take AP Calculus or any calculus beyond this class, this is a method that you will have to do. Okay, so you can do it. It's just a little slightly technical. Okay, so the reason it's so hard is because what is the derivative of my u? 4. Yeah, right? It's probably okay to swear in that scenario. So we have this x. Okay, so this is going to require some fancy footwork. You ready? Okay, so when I derive it and it's not the same as the outside, there's a step that I have to do first. Okay, the first thing that I'm going to do is I'm going to take my u and I'm going to solve for x. Okay, so you see my u right here? I'm going to take that and I'm going to solve for x. So how would I solve for x? So add 1, divide by 4, right? So everybody would agree that x is equal to 1/4 of u plus 1/4. And I wrote it in standard form because, okay, did you get u plus 1 over 4, right? I would add 1 divided by 4, right? Those are equivalent. So I like standard form because, why did I do that? Why did I separate it? Well, I just solved for x. Do you see my u that says 4x minus 1? No. Look. Okay, do you see what u is? What's u equal to? Okay, so I just took that equation and I solved for x. What? Because you have to add 1 and you still have a u. Huh?
The x equals should just be 1/4.
Well, I have to do all the algebra. Whoa, dudes. Okay, watch. Okay, if I'm solving for x, I start by adding 1, right? So I have u plus 1. Then what would you do to solve for x? See how we're like way past this? Because that's like algebra stuff, like algebra 1 freshman year maybe. Come on, guys. Follow me. Alright. So. No, I know you're there. You just gotta turn the brain on. Okay, so my next step now is going to be to derive what I have. Okay, so the derivative of x is dx. And what's the derivative of 1/4 u plus 1/4? 1/4, right? And what did I just derive? Du. Yeah.
But you derive the u.
Okay, you ready? So the next thing that I have to do is I have to rewrite my integral in terms of u. Okay, so I need to get rid of all of the x's. You ready? So let's see, I'm going to write this in blue. So the first piece I have is x. What is x equivalent to? 1/4 u plus 1/4. right? We just wrote that. Okay, then I have the quantity of 4x minus 1 to the fourth. How can I rewrite that with a u? U to the fourth. Nice. Now I have dx. What is dx equivalent to? Careful. 1/4 du. See where that came into play? So now we got to integrate. Now this is gross the way it is. So before I integrate, I want to simplify this as much as I can. Do you guys see how in my quantity I can pull a 1/4 off? You see that? So I have a 1/4 u plus a 1/4. Watch this. Pull that off. So then I'd have u plus 1. Okay, so now do you see I have 1/4 times 1/4 here? See those? What's 1/4 times 1/4? 1/16. And now I like to pull those way out so I don't have to touch them until the very end. I'm doing this very sequentially, by the way. Okay, now I want to get rid of my parentheses, so what would you do? Distribute that good. Okay, good. So u to the fifth plus u to the fourth. Now this is in its most basic standard form of du. This is going to be super easy to integrate. I can use my basic rule here. Oops, to the fourth. My bad, yep. That doesn't look right. Here it is again, that u to the fifth. I feel like this is on every one. Don't assume that all of these are, all U-substitutions are u to the fifth. Okay, so integral of u to the fifth. Integral of u to the fourth. We have a plus c at the end. And now what's my last step? Plug the u back in, right? So I'm going to have 1/16 times 1/6 times 4x minus 1 to the sixth plus 1/5 times 4x minus 1 to the fifth plus c. Now if you wanted to, you could distribute that 1/16 through, but that would be fine.
Wow.
So that's the type of problem that you will see as extra credit. And next year, if you continue with calculus, you will need to know how to do that. The good news is that the second time around, it will be easier.
Will they know how to do it beforehand, or
What's that?
like?
It will be easier because you've seen it, and also because everything that we have done is just going to be review. Like next year, we've done everything that you will be asked to do in AP Calculus. So with a few other extra things. Number 6.
Yeah, it just looks like
the derivative. Do you know what the derivative of secant of 4x is? So if you use your little cheat sheet, so secant, what was it? Secant tangent. So this is the piece that it is, right? Right here. So derivative of secant tangent is secant tangent. Yeah. So since there's a 4 on the worksheet piece, you just multiply by a 4. So for this, derivative of this is 4 secant tangent. So it's literally the entire outside piece. But you have to do a u to the fourth there though, because your secant's to the fourth. So your rewrite is just u to the fourth du. What?
Oh, what is the u? Where even is the u?
Where even is the u? What do you mean? Oh. Well, it's given to you here. There's no actual parentheses in this, but when you see something like a trig function with that fourth, like Trig is always the hardest one to identify because they don't use parentheses. But just so you know, a secant to the 4th degree of 4x is the same as the secant of 4x to the 4th. And I don't know why the calculus or the math god decided to write that little 4 after the secant. Maybe because that 4 exponentially might get confused with after the x, but.
So when you're writing the equation, it's 1/5 secant to the 5th, and then
1/5 secant to the 5th. Yep. Yeah.